Welcome, ladies and gentlemen. Welcome back to the CBAN Showcase 2020. If you're just joining us, this is the inaugural event by the Communications Business Automation Network, the ecosystem of ICT service providers and technology developers who work together to automate the business of communications to unlock the future of connectivity. In this session, we're looking at how automation is key to our industries even, because we have different use cases in different markets that overlap. That's going to be a theme for today. And our panelists will update us on work that's happening to define the reference architecture of the CBAN platform itself, and also the progress, plans, and particular challenges to be addressed for our first use cases. Just to quickly introduce our panelists, they are Andreas Freund of QLC Chain, Katie Chu of AT&T, Ranjal Vinchera of Telefonica, and Shahar Steif of PCCW Global. And before we begin, I would like to highlight a couple of items. One, please feel free to ask questions during the session. You can ask a question using the Q&A function on the bottom of the Zoom window. We will leave questions until the end, but ask them anytime it occurs to you, and we will get in questions at the end as time permits. And secondly, I would like you to feel free. In fact, I would like to encourage you to post extensively about the event on your social media. Use the hashtag CBAN Showcase. And with that, I'd like to begin with Andreas. Andreas has been key to shaping CBAN's reference architecture, which in a way defines the platform that all of the CBAN applications and MVPs use. And I'd like to turn it over to Andreas to talk about the progress to date, the learnings from that, and the direction for the future reference architecture at CBAN. Andreas, please take it away.
Thank you, Joe, and thank you for the invitation also to CBAN for inviting me to present to you today. Let's dive right in, because the reference architecture, or the bones upon which the CBAN ecosystem is being built as we speak. The design of this reference architecture was a 15-month collaboration journey. 11 carriers, 12 service providers working together through 4 in-person workshops before COVID then finally hit. And we all migrated to virtual meetings, countless calls, dozens. For some people, it was countless. Countless discussions during those calls, as well as offline, sometimes heated, but always in good spirit and with the aim to come to an agreement. And many during those 4 workshops, after our drinks, where trust was forged that allowed us to get to where we are today, which is the first DLT-based industry reference architecture. That is a true first, not only within the telco industry, but any industry. Next. So a couple of highlights here. So first of all, what's the purpose of this reference architecture? There are 3. Number 1 is to maximize choice of technology solutions for anyone. That means no vendor lock-in. Secondly is future-proofing, right? We want this ecosystem to exist for decades to come, which means we need to look ahead. And then thirdly and lastly is to maximize the scalability in terms of both the MVPs, the minimum viable products that can be supported by this reference architecture, as well as the participation by both ICTSPs and service providers in the CBAN ecosystem. So what do we have? So we talked about MVPs. The outcomes of this discussions, I just on the left, I'm very high-level pictorial depiction of the reference architecture. It's mainly MVPs and core services. So the MVPs, these products, especially something that Teddy and Randall will be talking about in a moment, They must be functionally interoperable, which we call east-west interoperability. That is key to avoid vendor lock-in. So it means that if you have a data on-demand settlement solution running on one stack, it has to interoperate across the business process of settlement between another stack that offers the same capabilities. It can be built on any CBAN endorsed DLT chain, DLT, which is important because that avoided the DLT stack wars, and it must utilize the CBAN core services. So think of the MVPs as the trucks running on an interstate in order to move goods from the farms to the store, and the core services are the interstate. So you can only get from the farms to the store through the interstate, right? Which means the MVPs can only do their job in a trustless manner if they're utilized. And we settled on 3: identity, which in order part of the future proofing is going to be compliant with decentralized identifiers and verifiable credentials from the W3C. We'll have assurance, so that's proof of correctness that the MVPs actually work as advertised, that can be checked by anyone. And governance, that means secure voting of the CBAN members, as well as the introduction of reputation around governance itself. So those are very forward-looking and future-focused services, and they must be compliant with an omnilateral, so interoperable, and omni-chain multiple DLT delivery model through CBAN signatory members. So these core services will be operated through CBAN signatory members, and anyone who wants to run an MVP can access those core services through these signatory member nodes. Next. After having given this really high-level overview, it's time to give thanks, share learnings, and take a look at the road ahead. Many thanks to Mark and Louisa for their leadership, Elena and Yussi for great support, and especially patience with a capital P. And then so many contributors. It's amazing, and it was so wonderful. It was, you know, Joe, Shahar, Stefan, Gal, Salvan, multiple Michaels, Susan, Odette, Mani, Andy, and many, many, many more. I think we had up to 50 participants, which brings me to the learnings. Collaboration between competitors is possible. That's one of the really big learnings out of that, which is, you know, it's hard, but it's possible. DLT stack wars are not necessary. Was another one of the big learnings. You know, we don't have to fight over whose DLT is better. Just use them all. And then interoperability is a must. Again, those are the 3 key learnings, and they are represented in the architecture. So what is the road ahead? It's to approve standards, the standard, and start endorsing DLTs such that we can build the core services for which we need to find funding. And once we have that, the endorsed DLTs, the funding, we start building. And sooner rather than later. And with that, back to you, Joe.
You're muted, Joe.
Probably helps if I unmute. Thank you for that, Andreas. Thank you for leading us through getting the architecture in place and for a very positive trajectory going forward. And now to look at some of the particular use cases and MVPs that we want to address on top of this reference architecture, let's turn to Teddy, who will be talking about international voice, and in particular, the issues around fraud in international voice.
Thank you, Joe. Appreciate it. I have the honor of leading the voice working group in the last 18 months or so. And it has been fun activities because it had a lot of dialogue, discussions among all the carriers involved, people from different continents coming together and try to make sure that their requirements are captured in the document. So I'm pleased that we at least have some common understanding of what we want to do. So let me talk about the high-level functionalities first. Sahar, could you move to the next slide, please? We basically come down to what we're going to use blockchain for. Now, there's always a common myth, or people just jokingly said that blockchain is a solution looking for a problem. We certainly don't want to do that. So we start off by looking at the business problem first to see what is the pain point, what are the things that inter-carrier commerce are experiencing today, and what we can use blockchain as a tool to solve those problems. So one of the key things that we identify is that there's really no standard way of sharing CDR, call detail records, when there's a dispute. And whenever we have a dispute among the carrier, it takes very manual intensive process. So we try to automate that process. And one of the key areas that I felt very passionate about, and especially from AT&T point of view, that's one of the key reasons we participate in these activities, is the detection and identification of discrepancy, and especially fraud-related discrepancies. And finally is how do we resolve when there's a dispute and make sure that the process is as seamless and effective and efficient as possible. Next slide, please. Well, when we look at international voice call, and all the carriers here will agree that we have really a number of transactions we need to focus on. If you look at the high level, right, the one that we have been doing for many years, which is the rate notifications, that's how we send the A to Z list among all the carriers. That process itself is pretty much automated now, and many carriers use different vendors or they build their own rate list generation and receipt. I would think that that is a pretty automated process already. As a matter of fact, these are the things that we know who we send it to. So there's really no problem as far as transparency is concerned. And you talk about invoices and delivery and receipts. We also know who we send the invoice to and who we receive from. The invoice itself is not the biggest problem. Payment also, as the number of wholesale carrier has come down, the number of payment and business relationship also have come down. But one of the key things that is still very high is the number of call transactions or CDRs being exchanged. As you all know, that when we send voice traffic from carrier to carrier, there's no guarantee who are the intermediate carriers who are going to pass the call to the next destinations. And very often in the fraud situation is one of the carrier might short stop the call, meaning that they don't really pass the call to the destination, and they would start charging you, especially for some of the very high cost, low usage countries, destinations. What we think about using blockchain is if we can have a way of provide some transparency in the transaction, in this transaction, not necessarily exposing the actual rate that each carrier pay each other, but at least have a proof that the call actually arrives at the destination. I think that we can use that information to ascertain that what we are buying from an originating carrier point of view is indeed what we are getting, right? Meaning that I'm buying a call to send to these countries, I expect the call to be delivered to this country. So if we can use blockchain down the call path, and each carrier can record their transaction, it's very possible that with that information, any carrier can tap into the information, being able to prove that they have passed the call downstream, or they have the call has arrived at the destination carrier. So one of the key things that we want to encourage, and that's part of AT&T desire to participate in the CBAN forum, is to recruit as many carriers as possible to be part of this the chain. And as you know, blockchain is only successful when there's a large number of carrier participate. So we fully support this, and hopefully there will be more industry carriers, and not just the big carrier, but especially smaller carrier who can benefit from this, and we can also help to screen out a lot of the fraudulent traffic in international voice today. The next slide, please. So what are the key functions that this voice international settlement transaction using blockchain can provide you? One of the key things we talk about is CDR. We actually have defined what are the minimum set of CDR information should be included in the data. And that will provide what we call a single source of truth, because both carrier on the transaction will write to the chain and being able to record that this is what happened. Now, we also recognize that it's not realistic to expect every single call to be recorded in the chain. So we focus on the summary level CDR, meaning that either on a daily basis or hourly basis, depending on the arrangement between the carriers, they will write a summary level of CDR of destinations that they have exchanged traffic with. It's using this summary information, then the system on both sides can then automatically calculate whether there's any discrepancy and being able to reconcile those differences. And the discrepancy management would be the key benefit for many carriers, because you are now spending a lot of time manually scouting through the CDR, comparing data, asking out a carrier to give you CDR. That's a very tedious process. And hopefully that you can identify any discrepancy before you even issue the invoice or receive the invoice from the other carrier during the month, and be able to reconcile and correct whatever the problem might be, even before you handle a dispute. So that really is the benefit, key benefit from a settlement point of view. The other side that we also talk about is on the fraud side. I explained a little bit about the concept previously. Really, the most important thing is to verification that the call actually arrived at the destination. I do want to point out that in our discussion, we deliberately stated that we are not advocating, at least not now, using blockchain to detect or to provide real-time call fraud verification or detection or blocking. That's not the intention of this project. What we're trying to do is, if there's a fraud situation or a call being short-stopped, which is the majority of the fraud in international voice today, that we have a way, or the carrier have a way to verify whether the call arrived at the destination. And we believe by promoting this arrangement, some of the bad actors will also shy away from actually even participating or try to inject themselves in the middle of the call, and hopefully will help eliminate those fraudulent calls as well. The other benefit, and many of our European partners, carriers has advocated, is that we can also use the blockchain information to verify origin-based rating. As you know, in Europe, many carriers charges based on where the call originate within the EU or outside the EU. So this would be one way of verifying that the CRI information is indeed protected and is not being altered as the call goes through the network various carriers. And also we can use this to streamline the stop payment requests. In AT&T, we strongly believe that if the call is fraudulent and never arrived at the destination, we should have the right to stop payment. And I really think that everybody will agree that in order to stop the fraudulent activity, the most effective way is to stop the payment. When there's no money, then the fraudster will move on to the next things. And hopefully we can also use this, eventually get to some kind of blacklist, right? We know that some of these numbers are bad, and over time, the blockchain can collect those information and maintain a database that all the participating carriers can benefit from. So this really is the high level functionalities. I'll be happy to discuss with any carrier interested to give you more information, or you can download the white paper from the CBAN website as well. Back to you, Joe.
Thank you, Teddy, very much. And I can see we've already got some questions coming in. And I wanted to say that the topic of fraud mitigation is also going to figure prominently tomorrow in the members only day. We have people coming with some specific ideas and talking about how we can go forward. So everybody there who's interested, I encourage you to come back tomorrow for Members Day. If you're not a member yet, talk to Elena. We can fix this overnight. And Teddy, I don't know if you want to take a minute here and just address the question that came in from Daniel about anybody else that you can name who's interested in working on this, or should we save all the fraud to Members Day tomorrow? I'll leave that up to you.
Well, I'll just touch on this briefly. Say yes, there are carriers interested. I can't rename names at the moment, but it's really just takes many more carriers for this to work, right? Because the nature of the chain is that even if I have five, let's just say 5 major carriers who participated in the voice stream, or say they're interested, they really sign on, that still couldn't completely cover all the major destinations. As a matter of fact, most of the fraud countries destinations are the smallest carrier in Africa, Middle East, high cost country. Those are really the carrier you want to target and try to recruit as part of this effort.
Fantastic. Thank you for that. And I think there may even be a tie-in with our next presentation. So Randall, from the mobile roaming perspective, could we hand over to you?
Sure, Joy. Thanks. This next slide. Okay, many thanks. It's my honor to be here representing the roaming group. I must confess here we are the freak guys, let's say somehow, because we are a hybrid group working to different associations. But it is important that you understand our role here, and as well the contribution that we are bringing into the CBAN and the other groups. Next slide, please, Joey. So in order to start my presentation, I would like to first of all to explain a little bit the problem or the situation that we have right now in roaming. As you know, roaming is a business that is running since a long time ago, and we have in somehow a lot of standards to manage this business. The problem is there is one section of this process that is still very manual, that is the settlement process. This settlement process today is managed by some special group within each operator, and is, as I said, very manual. And I would say that is something that we can keep as it is right now. The problem is new technologies that are coming and the new way that we need to manage to control our business and to deal with our business on a daily basis. It is forcing us to change radically and to bring new technologies, new ways to do things that will help us to be able to manage what is coming. Just to clarify more at this point, we need to be able to solve the situation that we will have, for example, with 5G, where we will have a lot of slicings to be managed and to be settled in a different way. So meaning that we will increase the amount of settlement casuistics, and that we need to manage in somehow more automatically, because it's something that we can't manage in the current way. In addition, we have a technology issue that is TAP is not more covering this type of technologies. It's an additional issue that is today partially covered by the new standard BCE in the GSMA, but that we see here an opportunity with blockchain to improve the situation and to bring all this scenario into something more efficient for all. So what exactly is the purpose of this group? So for us in the CBAN, this roaming group has two main purposes. The first is to create a cooperation environment between the CBAN and the BWR, that is the group in charge of the blockchain initiative for roaming in the GSMA. And in order to keep this cooperation, what the first point that we're covering is to keep both sides informed about what is done in each part. So we're having, as most of you already know, we're having tips of this observer group where we are trying to explain what the progress is in the GSMA and to bring that knowledge into the CBAN. And in the opposite way, what we are trying to do is to take part of the knowledge that you have already for other services and to bring that knowledge into the GSMA. Because, and this take me to the second point, we want to create an interoperation between what we are doing in the GSMA and what we are doing in the CBAN. What we see is make a lot of sense to keep these both consortiums synchronized, because we see we will have to deal with an operation on both consortiums, and we don't want to have two different platforms, two different technologies for everything. So, and here the CBAN has a large experience on this topic of interoperation, as Andrea said already. And I like a lot this message sent by Andreas about the DLT. So it's not a topic of competing. We are in a new world that definitely the collaboration between all operators, consortiums, etc., is a must to be able to have succeed in this new world. Taking a little bit further into when we will have things, I would like to remark a couple of dates. First, in the BWR, we are working to have our first MVP implemented in beginning of December. And the idea is, as soon as we have this MVP, we would like to bring these results into CBAN and present, okay, guys, this is already done. This is what is up and running today. So let's start collaborating and working into an interoperation model. That will be something that we would like to have and to launch in February. In this step, I'm not saying we will stop the GSMA work. Of course, we will continue there because we have a lot of additional goals to the MVP. But definitely in February, we will start having more interaction with the CBAN, because is when we think we can start exploring a real interoperation model. So and here this take us to a potential second MVP that will be that our internal goal in CBAN, I think, will be to have something in July 21 interoperable between different DLTs. So this is ambitious, I know, but we are here to try to do things really innovating, not to just see how we progress in the time, let's say. Next slide, please, Joe. So just to clarify what the scope of the MVP is and the benefit that we expect from that MVP. The first of all, we are using BCE, Billion Charging Evolution, that is a standard of the GSMA that is ongoing. It's already partially already done, but it's still ongoing and updating different topics. We are using partially this BCE standard to create something that allow us to manage different services on this MVP. So what we want to cover as well is this contract conditions and to be able to share the grouped volumes in order to speed up the settlement process and to avoid these disputes that we have today between operators. As well, we want to apply this automatic discount settlement. So meaning that we just create a smart contract that is approved by both sides, and then the discount settlement is automatically done in the application. In addition, something very important for us in the VWR, we are working in having a really open source platform. When I say an open source platform, it means that I have, again, I'm today representing a group of operators that are working a lot in the VWR. And that and the collaboration has reached the momentum where even code is donated by these operators in order to create this open source platform. So, and I would like to remark this: we are collecting all this code to prepare this open source platform for all. In addition, we want to be able to cover different operational models. We want to be able to manage an in-house or outsourced model. It shall be on the operator side the decision. And as well, we are working hard in having a good governance model that allow us to manage the chain, but keeping our open source spirit. So as you can see here, the technology that we are using right now is Hyperledger, and the idea again is to be able to interoperate as well in the future with others. So what are the benefits that we are expecting from this? To speed up the settlement process, to reduce the reconciliation disagreement between parties, to provide a good base for a potential future e-payment, so to be prepared for whenever an e-payment could arrive, to improve the operations that we have today in the operators, to make easier and smart the process of the negotiation, and in fact the contract acceptance for both sides. So in general, to decentralize and optimize the reconciliation process for all the operators. Due to the short time, I can't not go deeper into details, but you know, we are really open and happy to clarify any questions that you may have. Joy?
Okay, thank you, Randall, very much. And really looking forward to the cooperation you're describing. And I'll just remind everybody, the session after this one will have a representative from the GSMA and the MEF and the TM Forum talking about how we can move forward together. So please, everybody, come to that. And thank you, Randall, for that motivation. Now, I'd like to hand it over to Shahar, who has been shepherding the definition for data on demand, which is one of the first new services which can take advantage of the CBAN platform. Shahar?
Thank you. I'm unmuted. All right. This session is about the DLT commercial operational framework for automated data on demand services, which is one of the MVPs that we're running through. And just a bit of context before we move on, I will start with a very brief recap of the ecosystem that was described by Mark yesterday. Then again, a brief touch on what supply chains are and what makes supply chains in the telecom world different. And then I'll discuss a bit about architecture. And again, somehow recapping Andreas Freund's slides in a slightly different perspective. And I will describe service lifecycle and how it all comes together. So about the ecosystem that we've mentioned, what you can see here is the digital ecosystem of the future. And on the left, you can see what would typically be today's access methods, which could be anything like a carrier or devices through a mobile, or data centers carrying devices, or customer sites. On the right side, we see more of the application side of the business, or the clouds, but they come together. They're no longer separate entities, they're together. What binds them together is data. It is data that we transport from one place to another. It is data that we store. It's data that we compute, and applications that use all those resources to generate this newly digital ecosystem. And that ecosystem runs through a supply chain, because typically there is no one single provider who can deliver all elements of service to a specific requirement or a specific user. So you need to use a supply chain, but the traditional supply chain, which you currently see on the screen, doesn't represent the reality of the telecom industry, because it's not that we go from one supplier to another supplier, and end up from raw materials turning into consumables. The reality in the telecom world is a bit more complex. Each of the participants, we call it here service provider A, service provider B, that could be any of the participants. It could be a data center, it could be a traditional telco, it could be a cloud provider, it could be an IoT provider, it could be an application developer. They have their own resources, connectivity, compute, storage. They have their own customers, and they need to somehow turn their resources into consumables that the customers can consume. And sometimes they need to use resources coming from other service providers, who, by the way, have their own resources and their own customers. And in many cases, we find out that we buy and sell from the same partners. Some resources we buy from them, some resources we supply to them, each to complement the services that they offer to their respective customers. So what we have there is bilateral trade between those two service providers, and this is what probably makes the wholesale the wholesale trade on the telecom side different than the wholesale trade in other supply chain scenarios. So having touched that, now let's try and look how that fits into our reference architecture. And this is basically a slightly different view on the same architecture that was presented by Andreas earlier. And what is important here is basically that we have two abstraction layers. First, we have a horizontal abstraction layer that divides the applications which sit on the top from the DLT, from the ledgers. And it's very important that we decided to keep that abstraction layer in order to ensure that we're not locked into a specific DLT and into a specific ledger type. Some members might want to use one ledger, others might want to use another ledger. We have to keep the applications abstract from the ledgers, so we are able to run basically any application on any underlying ledger. And by the way, that also gives us two types of ledgers that we're using. One, of course, is the omnilateral ledger, which is a ledger that all ecosystem participants are using. And another is the bilateral ledger, which is shared by bilateral partners who exchange information with each other. Those could be either a customer and a provider, or two service providers that exchange information with each other. We're not talking about the implementation of the bilateral ledger. It can actually be a private chain on a multilateral ledger, but logically, there's a ledger that serves only two members or only two parties. And then on the top, we have the vertical abstraction layers, or the LSO Sonata functionality, in other words, which basically abstracts an application from one carrier to another carrier to another carrier. So we can have an application that performs the same functionality, but is developed by different vendors. And as long as they meet a certain criteria, they can be abstracted from each other. And two carriers who bought an application, the same application, it could be, for example, mobile roaming settlement application, or fraud prevention settlement, or data on demand application. The same application, which performs the same functionality, can be delivered by two different vendors, but they would be fully interoperable through the vertical abstraction layer, which is implemented through the LSO Sonata interface reference point. So this is basically the reference architecture and abstraction layers, which are very important for the purpose of this to work. In order for all that to work, we need to have an agreed upon reference architecture and an agreed upon process. So first thing first, the reference architecture, what we defined again is derived from the MEF LSO reference architecture, MEF 55 for that respect. But we've made some additions to it. We've enhanced the way this architecture is implemented within a carrier. We are less focused on what happens between carriers. We're more focused about what happens within a carrier when they run through the service lifecycle. Let's just look at something very simple, which would be an order. How does an order flow through this reference architecture. And keep in mind, what we have here is SBus, BBus, SCO, SOF. Those are names you may have not heard of, but SBus basically means this is a selling business unit, and BBus is buying business unit. So the same carrier both sells to its customers and buys from its providers. And we have an SCO, which is supply chain orchestrator, which binds the supply side and the buy side into a service together with the internal delivery, which is the SOF, the service orchestration functionality, which handles the internal delivery. And underneath that, we can see the bilateral ledgers, an internal ledger, which is just any kind of ledger, and obviously the omnilateral ledger. And let's see how an order flows through. We assume that we already have a quote, and we've already checked that the inventory exists, and we've already given a quote to the customer. Customer has placed an order. So this is what happens. The customer places an order. So the buying side of the customer places an order with the selling side of the seller, and they log that on the DLT. The supply chain orchestrator then analyzes that order and identifies internal and external elements. So maybe some elements of that order can be delivered internally through internal resources. Some should be procured from external resources. So first thing it does, it checks with the SOF, with the internal order elements, if the internal order elements are available. Maybe we've quoted something and it's no longer available. If it's not available, the process stops. But if it is available, then we go on and update the inventory that this item is now occupied for service, and we start procuring the external service elements, for which we already have a quote. So we send a request for activation of an order of the external elements, and obviously we also log that request on the DLT. What happens now is once the seller has delivered the services, once they've accepted the order, they respond order accepted. They sign that on the DLT. Once all elements have been accepted, we are now able to send an acceptance to the customer and tell them order accepted, and we log that in the DLT. And after it's been accepted, obviously we also start delivering, but that's a different process which I'm not going to describe now. This is just an example of one step in a larger life cycle, and that larger life cycle is defined here in this picture. So first thing we do would be to go through an initiation of a requirement. We need a service, our customer needs a service. We go through a CPQ or a configure price quote process. We identify a solution to the requirement. We collect all the supply elements and provide the customer with a quote. Then comes the ordering, which you just went through. After ordering, there is a delivery phase where service is actually being delivered. After service has been delivered and activated, we're going through SOAM, which is service operations and maintenance, which basically actual performance of the service, measuring utilization, fixing faults if any, calculating rebates for failure to meet the SLA, and eventually, obviously, also the billing phase or settlement phase, which is where we settle the bilateral business between the two carriers. What you see here in each of those is a sequence diagram, an API sequence diagram, but we also have the same with the BPMN diagrams, which show you the flow, and that is the flow that actually goes across the three elements plus the internal elements. Three elements meaning the buyer, the seller, and the additional supplier, and the internal elements, which would be, as I've mentioned, the selling entity, the buying entity, supply chain orchestrator, and the internal orchestrator. So this basically is a service lifecycle in a BPMN flow, and that basically configures both the process and the architecture. Obviously, it is very important that we maintain a uniform information model in order to make sure that the data flowing through the APIs is indeed coherent and understandable by all parties. A few more things which we developed in the document were, of course, first a use case. What we see here is a very general use case, including 3 physical sites and 1 virtual cloud site. There could also be an application running on top of that service. We've defined the contractual structure of the legal document that need to be signed between the parties, which would be either an MSA and or a terms and condition, which would be more specific to an MVP, and an order form, which goes for a specific item being ordered. So we would have one MSA. We can have multiple terms and conditions for multiple service types or multiple product types, or we can have just a TNC. We do not need to have both of them, but we will have an order form for each and every element of service order. Basically, every time you pick up the phone and dial a number, dialing a number means you've signed an order form. And every time you turn on your video conferencing, that means you've signed an order form for a video conference. So you do not need to actually sign something. Activating a service basically creates a binding commitment on your side to pay the dues that are related with this service. This is a legal action. Pressing order is a legal action. And the last thing we've developed also was reputation management, basically a normalized reputation score. And reputation can be a reputation of multiple things. It could be SLA reputation. It can be other factors such as, for example, payment reputation or others. So basically, we've developed a weighted moving average that gives you a score between 0 and 10, or 0 and 9 to 9.9, and allows you to score the performance of various carriers or various participants in a supply chain in a manner that's ubiquitous. As an example, if you have 2 or 3 different possible paths from point A to point B, and you want to know the score of the participants, you do not necessarily know who the participants are, because typically you would not know anyone except for your immediate neighbor. Then you can use reputation to know about your non-immediate neighbors, about your distant neighbors. And if, for example, one of the participants, number 3 in the row, you do not have a clue who they are. They're not your neighbor, they're your neighbor's neighbors. If they claim they have 5 nines in the rest of the day, and their neighbors claim, sorry, they don't perform that good, then you might want to think twice if you want to go through that route versus the other route, which allows you, and obviously blockchain now allows you to ensure that reputation really works. One of the thoughts that we're discussing, yep. Are we
Speaking
running
of
out of time?
immediate neighbors, we're running up against our next immediate neighbor in the schedule,
Okay.
which is a session on working together to support the industry as a whole.
So that's
we're actually
my last slide. So that's it. Thank you very much.
Yeah. So sorry, we have more content than we have time. But
that was the last slide.
I would encourage everybody to take a short break and come back when we will be talking with leaders of the industry groups that represent the different areas for these MVPs that we've been talking about. So thank you, everybody, and see you back shortly.
Thank you.